All right, so we are going to be putting together lots of information that we already know today to answer kind of a multi-step problem. I want you guys to notice that at the bottom here, there is a Melcon setup. You guys know Melcon from your English arts classes or maybe other classes. We're going to use that format today because it actually fits really well with what we're trying to do, because we're trying to give an answer to a question and prove using the information that we have. Okay, so we're going to use Melcon to answer the questions. But first, before we even get started, you're going to see a graph and a set of ordered pairs. Anytime you see a graph and a set of ordered pairs, the first thing you should probably do is graph those ordered pairs. Remember, we're graphing ordered pairs. We're not doing slope right now. Okay? So we start left or right or along the x-axis, and then up or down or along the y-axis. So our first point is -1, 1. So I start at the origin, I go left 1, down 1, and I plot a point. My second point is 0, 1. So I'm not going to go anywhere along the x-axis, but I'm going to go up 1 along the y-axis. If I were to write an equation for this line, what would my y-intercept be? 1. I've already plotted it. All right, next point, 1, 3. So I go over 1, up 3. Then I go over 2, up 5. Then over 3, up 7. Oops, sorry. I did that last point one place too high. So this one is not correct. Okay? When you're plotting points for these activities, when you're graphing, I want you to plot every single point, because one point could change the answer to your question. All right, I always need to connect my points to get some sort of line. If my points are all over the place, you guys saw some of those graphs last week that were like this, up, down, up, down, up, down, or maybe they were like circular. You need to try to show some sort of line with your graph. Connect them somehow. All right, so step 1, we're going to plot all of our points. We're plotting the ordered pairs. Okay, so you're going to see 2 questions later on in the week. The first is, does the graph show a linear relationship? Everybody look at the word linear. Any guesses what that means? How you would look at a graph and decide if it's linear? What do you think the word linear means? It means line. Do we have a straight line if we ignore this little point that Miss Levengood accidentally plotted? Do we have a straight line?
Yeah.
Yes, that's all we have to look for to answer if the question is linear, or to answer the question, is the graph showing a linear relationship? We have to find a straight line. Okay, so off to the side, right? Straight line. If I have a horizontal line like this, is that linear? Is that a straight line? Yes. If I have a vertical line, is that a straight line? If I have something with a positive slope, yep. What if I have something with a negative slope? Draw all of those if you haven't. All of those include straight lines, so no curves and no like up and down. And it'll be very clear to you guys as you're doing these whether or not they're linear. Like the practice problems that I gave you, it's either a straight line or it's all over the place. All right, so we're going to answer the question, is it linear?
Yeah.
Okay, we've already answered that, but let's look at the second question. Does the graph represent a function? Do I have a function? What do we use to decide if it's a function by looking at a graph. It's a test. What did we use last week to decide if a graph represented a function? Thank you for looking at your notes. Go ahead.
To be a function, each x value has to have exactly one y value.
Perfect. So each x value has to have exactly one y value. We looked at a graph and we saw we used a certain kind of test. What was it called? What was it called? The vertical line test. Okay? So for each x value, like Juan said, can have only one y value or exactly one y value, then we have to be able to draw a vertical line anywhere along the graph, and it only passes through the graph at one point. So everybody take your pencil right now. Put it on the left of your graph. Okay? If I'm going to go through my graph at any point, and mine's kind of thick so it's harder to tell, at any point, is that going to pass through the same or two spots at the same time? No, right? Look, if I drew a vertical line from here to here, it only passes through at that one point. If I drew a vertical line from here to here, it only passes through at that one point. If I drew one right down the y-axis, it would only pass through at one point. So we're going to use the vertical line test. We could also go back to our ordered pair and see if any of our x values repeat. Both of those are acceptable answers. You can use your graph in the vertical line test, or you can look at your ordered pair, but you have to be able to do at least one of those. You should be able to do both. Okay? All right, so now this is where we're going to use Melcon. So our main idea, we're going to answer these two questions. This graph does or does not represent a linear relationship. What'd you guys say? Is it a straight line?
Yes.
So it does represent a linear relationship. Okay? This graph also does or does not represent a function. Does. Because it passed the vertical line test, right? So the first thing we're going to say is it linear and is it a function? So we're going to answer that in a sentence. This graph does represent a linear relationship. This graph also does represent a function. So we're just going to answer those two questions, yes or no. Then, in our evidence and our link, I put those together because they're the same thing when we're talking mathematics, right? We're going to look back at our graph. We're going to look back at our ordered pairs to answer the question, okay? I can tell that this is or is not, let's circle is because we said it is a linear relationship because the graph does have a straight line. So now we're just proving.
Well, that's just straight.
Okay?
Just straight.
So it does have a straight line. So we said that we're going to look at the graph and see if it has a straight line. So we're proving what we just said. Now we're proving whether or not it's a function. I can tell that this is a function by looking at the graph. And we're going to answer both ways here. So first we're going to talk about the graph. By looking at the graph, I used, what was the name of that test? The vertical line test. Okay, so we took our pencil and we went across. We drew several vertical lines to make sure they only pass through the graph at one point. Okay, so we use the vertical line test. The other option, and I'm going to put it in parentheses so that we know that it's a separate choice. So you can choose to prove by looking at the graph and using the vertical line test. Or you can choose to say, I can tell that this is a function by looking at the ordered pairs and then our sentence starter doesn't really make sense here, but if I looked at the ordered pairs, what am I looking for to see if it's a function? That none of the x values repeat, right? So I can tell that this is a function by looking at the ordered pairs. None of, here I'll put that in parentheses so we know it goes with ordered pairs. None of my x values repeat. Or you could say that each x value has exactly one y value. Okay, so in the second part we're proving. It's not enough just to say it is a function, it is not a function. It is linear, it is not linear. You have to be able to say why. How do you know? Did you look at the graph? Did you look at the ordered pairs? What evidence did you use to say this is or is not linear, this is or is not a function? Okay, for the conclusion part, you're just restating what you said in the main idea part. So the graph does show a linear relationship and does represent a function. For today, you're going to conclude. That way you're saying it twice just in case. When you do this on your quiz, you won't be asked to conclude, but you will be asked to say whether or not it is a function and prove it, and whether or not it is linear and prove it. And say how you know. So here's what you're going to get today. Look familiar? Okay, exactly what we just did, different set of ordered pairs. On the back, I have taken away all of those sentence starters, so you're going to plot these ordered pairs and then write that paragraph without the help of the sentence starters, because you have to be able to do that on your test. All it's going to say is, does the graph show a linear relationship? And then under it, it'll say, how do you know? And then, is the graph representing a function? How do you know? Okay, so that is your task for today. If you finish both sides of this paper, your next job is to get this glued into your notebook, and then that Quizlet is still on Google Classroom. It is great extra practice. There are games, tests, flashcards, everything you need.